Greetings. Our project is image colorization using GAN, and we are team number 60. So we all have seen pictures and photos that our grandparents or parents have shown us, and some of them which are older than the others may be black and white. So we decided to take up a project where we could colorize these black and white images, which will be a nice way to relive those moments for the elders, and we also could get to see iconic moments from the history in color. Coming to our baseline model, as you might know, when we load an image, we get a rank 3 array with the last axis containing the color data of the image. These data represent color in the RGB color space, and there are 3 numbers for each pixel, indicating how much red, green, or blue the pixel is. We also have another color space, which is the LAB color space, where we again have 3 numbers indicating the data of each pixel, where the first number, L, encodes the lightness of each pixel when we visualize this channel. And this appears in black and white. A and B channels encode how much green, red, and yellow, blue each pixel is. So we decided to use the LAB model, as when we have a black and white image, we already have the L data. We just have to predict the A and B channels. Coming to our data set was taken from Kaggle. And the dataset contains both black and white and color images. There are 5 kinds of images in this dataset, which is drawing of using watercolors, works of painting, sculpture, graphic art, and iconography. So this was the main loss function which we used. So the other loss functions which we used are the loss G, which tells how close to the real images are this images produced by the generator. Loss D tells how well the discriminator is able to distinguish between generator produced images and the ground truth images. Loss G GAN is indicative of how well the generator fools the discriminator, and loss G L1 is our usual L1 loss. So coming to the generator and discriminator, our code implements a unit architecture for the generator in the GAN. The unit is constructed iteratively, adding downsampling and upsampling modules at each step until it reaches the input and output modules. The number of layers is increased gradually, and the middle part of the unit is built first, followed by the downsampling towards the left and upsampling towards the right. Coming to our discriminator, the discriminator is responsible for determining whether an input image is real or fake. The model consists of several blocks, and each block contains a convolutional layer, a batch normalization layer, and a leaky ReLU activation function. The first and the last blocks are exceptions for this. We have also the code also implements backpropagation in both the generator and discriminator. So in our work, we utilize the pre-trained. We utilize the model which is the GAN, and we have implemented pre-training for the generator, and we plan to pre-train the generator again on VGG16 to compare which gives us a better result. So as you can see the results, we have the grayscale image, the predicted image at the first epoch and predicted image at the 75th epoch, and the original image. You can see that as the number of epochs progressively increase, the image gets closer and closer to the original image. So in conclusion, we have our GAN model, which is pre-trained with the generator on Resonate 18. And a quick rundown of our result is as follows. The loss D, which ideally should be as close to 0.5 as possible, is 0.49 here. And the loss L1 loss is 3.2, which can definitely be improved. So we plan to improve this by training it on VGG16 and compare the results and conclude which is the better model. Thank you.